In this video, you are going to learn about galvanic cell. At the end of this lesson, students should be able to describe the operation of voltaic or galvanic cell and state the function of a salt bridge. To know the operations, we must know first what happens at anode and cathode. The oxidation takes place at anode. The electrons are given up by substance being oxidized and leave the cell at anode. While at cathode, reduction takes place. The electrons are taken up by substance being reduced and enter the cell at cathode. To understand further, we look at this galvanic cell and what happens at zinc and copper electrodes. At anode, the zinc electrode undergoes oxidation and release electron. The zinc 2+ will enter the zinc sulfate solution. The equation would be zinc solid dissolve into zinc 2+ and release 2 electrons. Thus, the zinc electrode becomes thinner. While at cathode, the electrons released from the zinc electrode will move out through the wire to the copper electrode. The Cu2+ from the solution will gain the electron transfer and undergoes reduction. The equation will be Cu2+ plus 2 electron and produce Cu solid. This Cu solid produced will deposited at the copper electrode, and so copper electrode becomes thicker. To complete the electrical circuit, the solution must be connected by a conducting medium through which the cations and anions can move from one electrode compartment to the other. This requirement is satisfied by a salt bridge. So what is a salt bridge? A salt bridge is an inverted U-tube containing a gel permeated with solution of an inert electrolyte such as KCl, Na2SO4, KNO3, or NH4NO3. The functions of the salt bridge are: first, it helps to maintain electrical neutrality. Secondly, it helps to complete the circuit by allowing ions carrying charge to move from one half cell to the other. What happens if there is no salt bridge? Look at the following diagram. As the zinc rod dissolves, the concentration of zinc 2+ in the left beaker increases. Then the reaction stops because the net increase in positive charge is not neutralized. This excess charge build-up can be reduced by adding the salt bridge. To understand further, let's look at how does the cell maintains its electrical neutrality using a salt bridge. First, we look at anode. The equation is zinc solid dissolve into zinc 2+ and release electron. So, here we know that the zinc 2+ from the dissolved zinc electrode will enter the solution. This increases the positive charge in the solution. So, what to do? The Cl- ions from the salt bridge will enter into zinc 2+ solution to neutralize the increase in positive charge. While at cathode, the equation is Cu2 plus 2 electron produce copper. The Cu2 comes from the solution, while the electron is taken from the electron transfer from anode. When Cu2 leaves the solution, this means that the solution now has an increase in negative charges. To neutralize this negative charge, K+ ions from the salt bridge will move into the Cu2 solution. Thus, the negative charge increase in cathode will be neutralized, as well as the positive charge increase in the anode. So, that's how a salt bridge maintains electrical neutrality. That's all for this video. Thank you.